Alright, welcome back guys. So far in our previous video we discussed about bisection method and the method of force position, where we are talking about the distance from here A, we got here A, we got here B, and we find for C. We talked about it in bisection method and the method of force position. So here we will be talking about Newton's method. Newton's method, I will try to highlight it for you, give you an idea of Newton's method, what is it all about. Then we will solve one example. Here in bisection, I try to solve the one example with a very simple way. I try to show you the easiest way of solving it, how you will get it using just a line. Do one or two calculations, you solve your distance, you solve your for C and find the midpoint. So here I will try to also solve this example. I will try to show you the easiest way that you can solve for Newton's method and find your value and your error. In Newton's method, we will show you also how to find the error, formula for error, and others. So let me try to give you a hint. Let me try to highlight it for you so that you will understand. When you are talking about Newton's method, the first thing you need to know is the intervals. Here, you have to know the interval from A to B, where it is all here. In A, in bisection before, we also know the interval. In force position, we know the interval, and we already solved for how we can find the intervals. So here, if you are talking about Newton's method, the first thing for you to bear in mind is the interval. You need to know the intervals. Then the second one you need to know is you will be given the function. The function, let's call it f of x. You need to know the function. Another thing you need to know is the second derivative of the function. All this we are trying to find. We will find all this when you will be given the intervals, or you can find it. We have already solved for how you can find it. The function will be given to you for like maybe your exam or your quiz or that. The function will be given to you. Then you can find the second derivative of the function. All this thing we are doing is for us to find what is our x now. X0. We have to solve for all this. Not all this, just one or two steps. You'll find your x now. So and our x now here in this method, our x now must be either this or this. If this is 1 and this is 2, our x now here must be either 1 or 2. That is how you know how your x now in Newton's method. It must be A or B. From the intervals we will take it, but we are trying to find what is it. Is it A or is it B? Is it 1 or is it 2? That is what we are trying to find. So here the function is given, the intervals, and we will find the second derivative of the function. When we find the second derivative of the function, we will try to multiply the second derivative of the function. Second derivative, we will multiply it with our function in the interval A, B. You have to put A in the function, put B in the function, then try to multiply it. It must give you positive sign. The one that gives you positive, one will give you positive and one will give you negative. The one that gives you positive is our x now. So you will put A in the function, know what it is, put B in the function, know what it is, then multiply it with the second derivative. It will give you, anyone that gives you positive is our x now. So one more thing you need to know is when you find x naught from here, we will have to find what is x1, x2, x3, x4. So our formula for that is x1 is equals to the x naught that you found minus put that x0 in the function divided by our first derivative of the function. This is our formula for finding the x1. Then when you're looking for x2, here will be x1, f of x1, and f prime of x1. When you're looking for x3, similarly, this place will be x2, x1. When we are looking for x3, this place will be x2, 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 and so on. So, and finally, when we have to find the error, and we know that our error here is x1 minus x0. That is what our error is. From here now, when this is just a first iteration, our x1 here minus what we found, our x0 here, will give us our error. So this is it. This is just the highlights of it. It is very, if you understand the basic, the way I highlight it for you, if you understand it, it will be very this Newton's method will be very easy for you to solve. Here we will try to solve just one example for you to understand what we are talking about. We will try to solve one example using this using this highlight I gave you. We just have to maybe just 1, 2, 3, 4, 5, and 6 steps, and your Newton's method is solved. So let me solve one example for you so that you will also understand what I'm talking about. Here, from here, let's say this is our function x squared minus 5 is equals to 0. Here this is our function, and we are given the intervals as let's say our interval is 2 and 3. We already know how to solve for intervals from the previous video. Either you use bisection method, either you use graphical method or separating it, so you can find the intervals. So here, this is our function. Our function is given, and they said use Newton's method to find the error. So what are we going to do here? The first thing, as I said, from the highlight, this thing I gave you, so from here we already know the interval a and b as our 2 and 3. So, and we know the function here. This is our function. So the third step you will do is for you to find the second derivative of the function. We are looking for what is x now. So we have to find the second derivative. Okay, let's solve for second derivative. From here, the first derivative is 2x, and our second derivative is 2. Now we already found the second derivative here. Now we are here. Our second derivative multiplied by our f of a and b will give us positive. Okay, so then let's look for the one that will give us positive. Now we have our second derivative. What is the next thing to do? The next thing for us to do is put a and b into the function, know their sign, multiply it with this to give us positive. Now let's put our interval into the function. Let's take our 2. From here we say 2 squared minus 5 is equals to, what is this? 2 squared is 4 minus 1. Then 3 squared minus 5 is 9 minus is 4, positive 4. You see, now we've put in our intervals into the function, and we found minus 1 and 4. Now what is the next thing to do? To multiply this with this to give us positive. If you multiply this, 2 times minus 1 will give us minus 2. 2 times 4 is 8. So this and this give us positive, which means that here is 3. We put 2 here, and we put 3 here. Okay, so if you multiply your second derivative with this, it gives us positive. When it gives us positive, which means our 3 here, the one that helps the second derivative to give us positive, is our x now. So from here our x now is equals to 3. Why? Because this guy here is the one that helps the second derivative to give us positive. Okay, so this times this is positive. So now it's 3 here from the interval. I told you here that our x now must be either a or b. So now from here we found that our x now is 3, not 2. So now we found our x now. What is the next thing to do? The another step for you to take is for you to find x1, and you already know the formula for x1. The only problem students are having is how to find this x now. If you can find this x now using these few steps, and find, if you can also know this formula off head, if you can know it off head, that means this method of Newton's method will be very, very easy for you. So now we find what is our x now. Then what is our x1? We already know the formula from here. We say that x1 here is equals to x0 minus f of x0 for x0 all over f prime of x0. This is our formula. Now we will try to know what is our x1. Our x1 is our x0, which is 3, minus, from here we know that our x is 3, minus f of x0. Put x0 3 into the function, we found 4, over put x0 into the second derivative. You see what I did here? Here f of x0 and f1 f prime of x0. So from here we already put our x0 into the function 3 minus this 9 minus 5. You see 5, 6, 7, 8, 9 is 4. So we write 4 here minus 4. Then put x0 into the first derivative of the function. This is our first derivative of the function. If we put our x0 here, which is 3, so 3 times 2 is 6. Is 6. Okay, so from here, let's just use our calculator to find minus 6. Okay, from here we found out that our x1 is 2.3333. 2.3333. Okay, now if you are asked, you see we've solved up to this point. There's only one point left, only one part left, just for us to find the error. When you solve for one, make sure you solve for error. Solve the other one, solve for error, until you get to the error they ask you to find, because they will ask you for a specific error. For example, maybe they will ask you 5 to the 9 minus 9. They will ask you for a specific error. So you keep solving it. If you solve one step, you solve for the error, solve another step, solve for the error. So from here, our error here is equals to, from here I've shown you the formula for error, x1 minus x0. So x1 minus x0. So from here, what is our x1? We say is x1 is 2.3333 minus 3, which is our x0 here is 3. So when you say this minus from here 2.3333 minus this should give us let me write it here. So it should give us 0.666 and so on. Okay, so this is how to find the Newton's method. Here you find it. The first thing to do is you're given the function and the interval, find the second derivative, multiply it with this function, put the interval and the function, the first one and the second one, multiply it. Anyone that gives the second derivative, anyone that helps the second derivative, let me say that way, that helps the second derivative to give you positive is our x now from these two. So we did that. Find our x now as 3. What is the next step? Substitute this, find the x1, multiply this, and find the find the error. Okay, so this is how to, okay, for example, let's go more one step. Now we found our x1. Let's solve for x2. Now our x2 will be x1 minus, this is when we are looking for x1, we use x0. Now we are looking for x2, we use x1 minus f of, this is x0, but this time around is x1 over prime of x1. Okay, this is it. Then when you solve this, you will find your x2. Okay, let me try to put it for you. This is x1. What is our x1 here? Our x1 is 2.2222, 2.333, I mean, minus, put x1, this into the function, to the main function here, put into the function here, then all over, put the x1 into the first derivative here, find it. Then when you're talking about, when you come to the error, you say that error is equals to x2 minus x1 will give you the error. So you keep doing this till you get to the error they ask you to find. This is the way by which you can solve for Newton's method. Newton's method is quite simple. If you understand the basic part of it, how to find the x. This is where students normally have problem, how to find the x now. If you find it and you know the formula, others is very easy for you. Know the error, it will be very easy for you. So this is how to solve this Newton's method. We have like 5 methods of solving it. This is the third one we solved. We have 3 more steps. We have 2 more steps, which is fixed point and second method. We will also try to solve it using another easy way. Here in our tutorial videos, we always try to show students the easiest way of solving questions. So this is all about Newton's method. Try to know these steps. This is for bisection, not included. So from here, try to know these steps. If you know this, only these few things, you can be able to solve for Newton's method. Thank you for watching. In the next video, we will solve for fixed point example, where we will also try to show you the easiest way of solving it. Thank you very much for watching. See you in the next video.